Bro, Clint, stop laughing at
Alright, so let's talk about B really quickly. Overall, B was correct across the board. However, I do want to push on a couple of things quickly, looking at some of these sketches that I see from students. Not that one, not that one, it must have been over here. So first off, make sure you label your axes. And I want to look at, nope, that's not drawn. Let's look at this. Why? Why?
Pull it down a little bit. You have to hold it straight forward.
It has to be straightforward?
Yeah.
Man, that's dumb. Alright, so looking at this B here. Anyone see one thing that I might push back on in respect to the characteristics that we see in the book?
It's not a straight line.
Okay? So does it have to be a straight line?
No.
No. It could be what else? What else could it be? It could be cubic. It could be, I would say, even say to the fifth. Right? It could look something like this. It just has to be an odd degree. Whoops, I missed the mark on that. But, right? So it just has to be an odd degree so that it does something like this. What do you see different about my purple versus that black? Black one's kind of shaky, yeah? So anyone see any other mathematical problems?
It's
It's kind of
up
going at a
instead of like.
weird angle at the end.
Let's let Jordan talk first because she was talking and then we'll go to what you're saying, Cole.
It's like spiking up. Wait, okay, the first one is like going up. And the left is like, you know, like curved.
Yeah, it's kind of going more sideways a little bit. So are you talking about here at the end?
Mm-hmm.
Yeah, so one thing I do want to point out, and you want to be aware of, when you look at the end behavior, especially with polynomials, and I see it a couple other places around the board, as the x gets larger and larger and larger, either towards positive infinity or negative infinity, your function is going to go more vertically than it is horizontally. Is it still going to go horizontally?
Yes.
Yes, very much so. But be aware, it should never jut off to the side like this. It should be going up and slightly to the right. So when you draw a cubic or any polynomial, make sure that you have end behavior closer to this right here, right, where it's more vertical than it is horizontal. Does that make sense? Okay, don't ever jut it off to the side. That's going to be, if you look at that rubric, it would be a P for procedural misunderstanding, because it's just not procedurally correct to draw a polynomial that way. So be aware of that. There is another issue that I want to talk about, and Evan kind of mentioned this, that it's shaky, right? Procedurally, I want you to look right here. Technically, is this even a function? Look at that line.
No.
What's, that one vertical line is intersecting the function how many times? Actually, one
3
here,
times.
here, and there. Lexi?
I was gonna say something about imaginary zeros.
Mm-hmm.
How it would do that. I don't know how to explain it, but
Okay, so let's look at that in a second. But does that make sense? Like that squiggle there would actually prevent it from even being a function, right? If you ever go back at all horizontally, it's going to prevent it from being a function. So let's look at this in terms of imaginary zeros. Now, a lot of times when we have imaginary zeros, it might look something like this, which, sorry, it's just such a tight, there we go. Boom. That could have imaginary zeros for sure, right? Could that work for this problem?
no,
Why not?
because it's not always increasing.
It's not always increasing, right? So we want to pay attention to that. Now, you can also have some imaginary zeros just by doing, so remember if it's cubic, how it can have that, it starts to flatten out near that x-intercept to increase the multiplicity, right? Now I have a multiplicity of 3 or so. But if I were to have it come through and then do that here, you see how the curve is up there and it's not at the x-axis? That would have imaginary zeros. Does that make sense? So it doesn't, and you were trying to do you did the squiggle to make it have those imaginary? Is that what you're trying to do? Isn't this where y'all were?
This one, no.
Oh, who was here then?
She couldn't reach it, and she wasn't.
Oh.
I cannot draw a cubic unless it's going through the middle. Like, I can't.
So it just takes practice. But does that make sense like that? Okay, so we need to practice with it. But yes, if it has that curve like this, it would have those imaginary zeros. And they wouldn't be there because these are all real numbers, but that would tell me that I have imaginary zeros. Because this x-intercept is a zero with what multiplicity? What did y'all say? Right here?
One.
It would have to be 1. We know it has to be 1 because if it was 2, it would touch and what?
Bounce off.
Bounce off. Also, on top of that, imaginary roots always have to come in what? Pairs, right? So it would be 1 0 there and then some pairs, a pair of zeros elsewhere. Okay, so let's continue to look. Any questions about B? By the way, could a linear function work there? 100%, right? A linear would constantly increase. I do like the look at cubics and quintics there to show some kind of curve. Part C. Okay, note here says we can't do it. C, can't do it. I have a C over here though. This C says not possible. And this C says can't graph. Oh, this is supposed to say not possible? Why was C impossible? Okay, so we can't have an absolute maximum or minimum with an odd exponent. Why is that? So remember that in behavior is going in opposite directions, right? So what's the maximum y value? Infinity. Is it possible to have an absolute max above that infinity? No. You can't. And don't forget, because I see students do this all the time. I see students in a case like this say the absolute maximum is infinity. Absolute maximum can never be an infinity. Because can you ever reach infinity?
Buzz Lightyear.
No. Yeah, Buzz Lightyear is way cooler than I am, that's for sure. But mathematically, we can't reach infinity. All right, not possible. So, and another thing to remember is absolute max and min, at least for our class, will only exist where there's a relative max or min, right? And if I look at an odd degree polynomial, it's going up to infinity on one end and down to negative infinity on the other end. So those relative max and min can never be an absolute. We clear on that? So the language I would put here, I would add more onto this. Can't be done, can't have an absolute value on an odd. We'll be careful with our language, right? Degree. So what I might say with that is this. Odd degree polynomials, like what is it that we're really focused on that's telling us we can't have an absolute max or min? What about that odd degree polynomial?
The odd degree tells you that it's going to, the end behavior is going to be very similar ways.
So have in behavior in
Yeah, opposite direction.
opposite directions, right? Right, that means that at some point my y is approaching what? Negative infinity and
Infinity.
positive infinity, right? Y is approaching positive or negative infinity, so a relative max can't be a what? What's this all about? Absolute max. Right. So y'all had the right ideas on there, but notice how we want to bring in more formal language. We want to be intentional about that proof of, hey, odd degree polynomials we know have this in behavior. Y is approaching positive negative infinity, so that relative max can't be an absolute max, and the same thing for mins, right? And so we want to pay attention to those details. Any question about that information? So if you think for the most part we got that, but just in case you didn't, make sure you correct your errors. Okay. D. All right. Okay. I will point out, if we look over here, I guess that's group 5, or maybe this didn't update it. Does anyone see an issue with the D that's over there?
It shouldn't be negative.
Like say it without you correcting me.
But if you don't say it, then I can't correct you to help you improve your understanding.
It shouldn't be under the X, should be above.
The arrow?
Like the whole graph should be above the x-axis?
Oh, wait, or is, they're both too straight?
It's going up like
Yeah,
that.
it should be.
You're talking about like the end behavior? I'm okay with the end behavior. It'd be nice having it a little bit more horizontal, but I'm okay with it. Cole?
The end of the curve don't have arrows.
Okay, and I'll say this. It's implied. I do prefer there to be arrows, but it is implied. There's another issue I have.
It's
Is it
un-
spread out more?
I'm okay with that.
it,
Is it because it's not labeled?
Ooh, should we label those axes? Notice one of the requirements is that we have a relative maximum at y equals 3, right? How do you know that that's a relative max at y equals 3? You don't. Always label your axes, ladies and gentlemen. If you do not, can't be correct, right? It can be roughly correct, but there's no way for me to say that D right there meets the requirements for that problem. Okay, and without justification, that would automatically drop to a 0 minus. Lots of correct details. Make sure you justify your answers, right? Identify where your 4x intercepts are, things like that. Okay, let's look at this D up here, right here. What do y'all think of that one? Good to go? Need to push back on it?
I don't know, I don't like the way it looks.
Oh,
What's wrong with it?
it's cute, it's like.
It doesn't have what? Oh, that's right. We're supposed to have how many x-intercepts for D?
Whoa,
Or
4. How many does it look like?
one.
One or five?
I was like, I can't really tell because
One or
it's just flying off.
five. One or five.
Right, if you're supposed to have 4 x-intercepts, make it 4 clear x-intercepts. Alright, so make sure we pay attention to that kind of idea. Doing pretty well for there, or for the most part after that. One thing I do want to, which one is y'all's?
again, label it, it's a 0 minus.
I will say your graph looks similar to your handwriting to a certain degree, but other than that, yes. I will say it does meet the requirements. Even that squiggle in there could indicate just some imaginary zeros, but it has the 4x intercepts, right? Is there a requirement that there's only 4 zeros for D?
No.
No. It only says 4x intercepts. In fact, I would point out, could it do something like this? Would that work for D?
Yes.
The end behavior works, right? 4x intercepts? Relative maximum of y equals 3? Okay. Notice that just because it's a 4x intercepts does not require it to be a quartic. It could be a higher degree based on multiplicities. Heck, could I have had imaginary zeros in there? Yes, right? It just has to be 4x intercepts. And so we do want to pay attention to that. One thing I do want to push back on, and I think for the most part, everyone else was good to go unless I'm just missing something. One thing I want to push back on from the language of the book is it says a relative maximum at y equals 3. Remember, the y value, the y is the value. So you would say a relative maximum of y equals 3, but it's at what kind of values? At x. Whenever we talk about relative max, it's of whatever that y value is, and it's at the x value. So the x indicates where stuff is located on a graph. Okay, so, but otherwise, yeah, I think that's good. Questions, comments, concerns about D? Sure.
No, you're not allowed to.
Well, you said it says can't be done right here.
4,
Yeah, but the graph's
3,
Oh. It has to go in the opposite direction. Yeah. Okay, so let's look at E here. I heard people very quickly talk about E not being possible. We do have an option for E on this back TV over there, and on the whiteboard over here. Does anybody want to push back on the E that we see on the TV or on the whiteboard, or explain why they disagree? Okay, so looking at E, Deja? Say that one more time. Does it look like it's a third degree?
Yes.
Sure about that? When I look at E, I will say this. I see 3x intercepts, but I know it can't be third degree. Does anyone know why?
Oh, because they're both down. Cause
When the end behavior is in the
it's
same
odd, it's like
direction.
this.
There we go, right? So, and that's one thing I would point out very quickly here with D. Notice on D how the end behavior is in the same direction, right? So I know immediately it has to be even. I look here at E, right? I know E on this whiteboard can't be, what is it I'm looking for? E can't be odd because the end behavior is in the same direction. How is that E over there an even though if I only see 3x intercepts? Not even looking at the whiteboard, guys.
I'm looking now. Sure says that.
Even though there's only 3x intercepts, why is this not an odd degree?
That one has a
Because if you move it down, it has more. Maybe possibly.
It does have one specific.
See that x intercept?
Yes.
See how it touches and then bounces off?
Yes.
What does that tell us?
Multiplicity.
That's a multiplicity of 2. This has a multiplicity of, and this one has 1 plus 1 plus 2 is
4.
right? So that's an even degree there. So why all the way across here do we see that E is impossible, but we have graphs over here? What does someone need to push back on about this graph? It has a degree of 2, so what does that mean? At most, if it's degree 2, you can at most have 2 zeros. So at most, you can have how many x-intercepts? 2. In fact, we should remember immediately, if it's degree 2, what shape should we be looking at? A parabola. So at most, 2 zeros. 2, this would be a parabola. So impossible. It's
I would never do that. It'd be so good. Have you seen it?
what? No, I'm not.
Oh, you got a baby.
I was like, I have a 4-week-old. Actually, he hit a month or Saturday. Huh? Yeah, take him to the movie theater and expect him to sit through a 2.5 hour movie.
Someone brought a baby to mine yesterday, and I about threw.
Somebody
Yeah,
brought
I
a
was
4-year-old
angry.
to Halloween
Okay.
Ends.
Any questions about this E? About why it would be impossible? Going once. Going twice.
So what you said, say it again.
I said, what questions do you have about this E?
She is in this class.
Yep, she is in this class.
Wait, why can't it be a parabola?
Bree didn't know because she chose not to show up, before lunch.
Dang.
3x intercepts. You can only have
Dang, why didn't get on you?
Alright, so I will point
Why
this
didn't
out.
get on you?
The talk that's on the next page, right? That is technically what's due today. We're gonna go over it tomorrow though, so hold on to it right now. And I will check it tomorrow.
Hold on.
Why can't it be a parabola?
You can still stand though.
Scan today?
Why can't it be a parabola?
Do that.
Collection was too sad this weekend.
He's not.
Okay.
What were we-
Okay. Get started on lesson 4. Lesson 4, function construction, okay? So, what we've learned a lot about are the characteristics of polynomials, but also last unit we learned about how to sketch polynomials from the factors, but you were always given those factors, right? this lesson, we're going to learn how to pick out appropriate factors and sketch polynomials based on those appropriate factors, based on whatever characteristics are given, right? So you've analyzed the characteristics of the graphs of functions that represent factors and use those characteristics to sketch the resulting product. So we did last unit, right? We have built functions with known end behavior and summarized our results. So how can you build the graph of a cubic or a quartic given a description, right? And so pay attention to your learning goals, right? We want to connect graphical behavior of cubic and quartic functions to key characteristics of their what? Factors. Last unit was all about those factors. We're bringing that back up into these polynomials. We're going to construct or create cubic and quartic functions given key characteristics and determine the number of real and imaginary zeros for a polynomial function based on its factors. Alright, before we get into all that though, what we're going to do is just this quick getting started. We're only going to spend a couple of minutes here. So we're going to sketch a set of functions whose product builds a cubic with these given characteristics. And explain your reasoning. Then list similarities and differences between your graphs and your classmates' graphs. So once again, you're going to work collectively as a small group, and I'm going to have you look at the graphs that other groups created. So the only requirements are that we have what zeros? X equals 0, x equals 2, and x equals -5. Now I want to point out this language. Does it call these x-intercepts? No. It calls these zeros. And it doesn't give any more multiplicity. If these are the only zeros, what does that tell me about the graph? Okay, yes, it's going to be cubic, but what else? Okay, but what are these zeros going to look like? They're going to be the... There we go, right? Are there going to be any other zeros for this graph? No. So can there be a higher multiplicity for any of these? No. Can there be imaginary zeros? No, right? These are the only x-intercepts, okay? So pay attention to the language of things, because if I tell you what the x-intercepts are, you could have higher multiplicities, you could have imaginary zeros, but when I tell you the zeros, those are the only options. All right, so move to wherever you want. I will say, you want to get different boards, or you want to stay where you are?
Stay where we are.
Stay? Anybody want to move? Where are y'all at? That chalkboard? Anybody want the chalkboard?
John, not chalkboard.
No on the chalkboard?
You want to go to chalkboard?
No one wants to move to the chalkboard?
We'll go to the chalkboard.
Chalkboard, alright, so move to your areas, let's start sketching out, and go ahead and do all of number 1 and all of number 2.
I wish I could be.
So get A done, B done, ooh, sorry,
My bad.
thank you. Quick clarification on directions. Do number 1 parts A, or do the explanation for A and B. Do not do the similarities and differences yet. And then do number 2.
Hey, James.
So do the first part of A and B, and then number 2. Cole, go to your group. Who's your group? Where were you? There? No. You were there? Go to any of the whiteboards.
I'm working.
Where was Walter? Go there. Okay. Oh, sure.
You're like the bully, James.
I've noticed. That's why I'm getting on to him. You worry about you. That's water. So yeah, you spray the rag a little lightly,
spray the thing.
and then you can wash the board. There you go.
Can you come in?
Spray the paint.
Exactly.
Are you recording, Mr. King?
Yeah, every time I walk that it's true. I thought that was like his own.
Put it down and work on the map.
Can I draw it? Is this some color? This is down here. I have purple. Well, it's odd. This one says
So we have to start here.
Yeah, I'm doubling up, I gotta go.
Where you go?
Can I see you next time? Oh, we need to, I hate it though.
Is that a question?
Because like, my glasses, I cannot use this.
Wait, we're doing it.
Oh, they doing it again? Yeah, no. I will do mine. Like,
Are we doing A and B? Right? You should.
Actively
We're
collaborate.
doing A and
A and B and number 2. And you're just not doing the similarities and differences.
They put me on
Say that one more time. Are they supposed to be polynomials? I mean, they are polynomials. Yeah, all of these functions that we're studying, quadratics, linear, cubic, quartic, quintic, all are polynomials. Alright, we should be through A. Let's at least get to B now or very quickly. And then complete number 2 as well.
And then when we try it, one of them is one of those things.
I'm going to.
It's a one of them. I'm guessing the four. I'm guessing something else. Same thing.
You made a call.
Slam them out, and everybody slam them out.
You guess.
You cannot do that.
What are you doing?
No, I'm not, I was just putting space on.
I'll turn it on.
I was putting space on.
I'm a big fan.
This one's easy.
Oh, wait, number 6 is this right?
Right here. Hey, lay down. Do you not see how far you are from me? Are they both having emotional needs too?
We're going with code laws for kids.
You can do it. You can make a motion.
You said it. Number 2.
Actually, hold off on number 2. Once you get done with B, move back to your group.
You want to see explanations?
No, we're going to talk about it in a second.
I guess they were drunk.
Make a
15, maybe 122. 20 more seconds. You should be done within the next 20 seconds. Five, 4, 3, 2, 1. Let's head back to our group. Bree, Lexi, Evan, James, head back to your group. Thank you. Okay. All right. Hey. So let's look again at our directions. What did the directions say?
Sketch a set of functions.
Deja, why'd you go ooh like that? Oh no, that's not. Sketch a set or 2 or more. What do they mean by sketch a set though?
Show the different possibilities.
Okay, maybe.
And they wouldn't have to be different.
Look at the language again. Sketch a set of functions whose product. Think about last unit. Yes, you have. We did. Maybe something like this.
Oh.
Would that work?
It's very much so.
Dang.
Nobody did that.
Nobody did that, did they?
Uh-uh.
That's pretty much all it.
Alright, so here's one option, right? You can sketch that out if you wanted. What else could I have done on, and I will say, I built this to give me something like this cubic right here. Notice what's a negative times negative times negative.
Negative.
Negative. See how those are all negative values? Now look right here between those x-intercepts. Positive times negative is positive. So notice, alright, that would create this scenario, maybe those lines. Is there another way that I could draw lines, maybe for this A right here, to also create that similar shape? Is there any way I could draw 3 lines to also 3 different lines?
Yes.
Could I do a parabola here?
Maybe.
Well, if I have a parabola, I need to go through 2 x-intercepts, right? And then in order for these to be negative, right, I would need to multiply a positive times a negative, right? So I might need a line now to go through that x-intercept. So should I have something like this or something like this?
That was
The second one, right? Would that work?
yes.
So that could have been an option. I would also even point out, ooh, that was almost bad. I got red mark all over my shirt. That would have been awful.
Would you cry?
I would have definitely cried. All right, could I have done this option with a linear here, a linear here? Man, I'm going all over the place. I'm sorry that there's so much on this board. Notice this would be positive, positive, negative. Would that give me this piece here? Yes. Okay, so what we want to notice, right, for A at least, what are the options that are possible to create that cubic function through those x-intercepts? By multiplying what? In order to create this cubic shape here, using those x-intercepts, what would we have to multiply? But I mean, here I had a positive and a negative, right? And then if I use the linear, it'd be 2 positive and a negative. But think more about the functions that we're multiplying. To create that cubic, what's possible to multiply? Guys, what types of functions are there on the board?
Linear and.
So I can multiply 3 linear, right? Which makes sense, because they each have how many zeros? Each one has 1 0, right? Say that one more time. Say that one more time. Think about it. What you're saying. Not a cubic and a linear.
Oh, quadratic.
Quadratic and a linear, right? Because a quadratic has how many zeros? 2. And a linear has 1, right? So, what we would want to notice, similarity, or in general, what we want to note here, to create a cubic, multiply, how many linear? 3 linear factors, or a quadratic and a linear.
That's the explanation.
That's the similarities and differences. Like if y'all had done a set of functions, right? Either you would have had to do a quadratic and a linear, or do 3 linears. Those would have been the options to create a cubic like that. Alright, before we look at others, I do want to look at this B right here. There is an error that we do want to pay attention to and learn from on this B. Does anyone know what it is? Has 3x intercepts? Why is that a problem? Yeah, they only gave us two x-intercepts with a one of them with a multiplicity of 2. Notice, would this even be a cubic? How do we know right away that end behavior is in the same direction, right? So be careful about that. Learn from that mistake. We want to notice those things immediately. So looking at this b here, again, to make that cubic, we would have to either have a, what do we have to have? Right, but what did we just talk about? To create a cubic, what did we have to have? A 3 linear or quadratic and a linear. How would I do that here, though? Any guesses? Any possibilities? What would I be able to do here to create a 0 with a multiplicity of 2 here, and a 0 with a multiplicity of 1? There's several options. I could do a parabola. Where would that parabola go?
Right there.
Where's there?
In between.
Right there, that'd be his vertex.
Right here would?
Yeah, but the dot would be a good,
Okay. I mean, that would literally have a multiplicity of 2, wouldn't it?
Yes.
Okay. What else would I need then?
Just do a line to the other side.
A line? Where would it need to go through?
The other x-intercept.
Go through the x-intercept right here? Right? Positive times a negative would be negative, right? Referring to this section over here. Positive times positive is positive, and then positive times positive is positive. I have a multiplicity of 2 there. That would work, right? Is it possible to have something else potentially? Could definitely flip it around. How about this though? Okay, that's my starting parabola. What would I still need though to create this multiplicity of 2 here? Oh, can I do a line through here? Say again. Right, like right here. So remember, I needed a multiplicity of 1 here. I've already got that with the parabola. And then here, when I put the parabola through right here, it gave me a multiplicity of 1, but I needed a multiplicity of. So I put my line also through there. Now, how many zeros do I have there?
30.
Just here. I have 2. Does that make sense, Evan? So it's 3, 1, 2, 3 overall, but because I have 2 functions intersecting there, it's a multiplicity of 2. Make sense? Okay, so that one's on me. I will definitely do better to pay attention to that and give better directions in the future. Number 2, though. Derek and Alex disagree over which functions, when multiplied together, build a cubic function with zeros, x equals 5 and x equals -1 multiplicity of 2. Derek says, hey, I sketched this parabola with that vertex there, and I have this linear. Alex is like, nah, I did 3 linear functions. Who's correct? Who has a function, a cubic, with those zeros and that multiplicity? Just Alex? Oh. So, is it possible to have more than one?
Yes.
Yeah. Notice Derek's, with this parabola here, that already has a multiplicity of 2. This line has that 0 right here. Whereas Alex has 2 linear functions going through that one point, creating a multiplicity of 2. And then this extra 0 over here. All right. So we're bringing together a lot of what we have learned. And so who is correct? Both, right?
Both.
Both have a 0. X equals -1 with multiplicity of 2. And 0, x equals 5. They just got it differently. Now, I will point this out. If they were to graph the product of their functions, do you think they would get exactly the same cubic?
No.
No. Could it be similar? Possibly. But I will say, I'm just looking up here, I know that the end behavior is different. Right? What's a positive times a negative? Negative, right? What's a positive times negative times negative? Right, so even that end behavior right away is different, but they could be similar, but they're not necessarily going to be the same. And that's okay, right? They both met the restraints or the constraints of the problem. But here, that's bringing us to activity 4.1, building a cubic function. And notice, when we build a cubic function, what type of functions do we have in this box? What are all of them? They're all either quadratic or linear, right? Because if you're building a cubic, the only options are to multiply linears and quadratics. Like that's the only way to make a cubic. If you have just linear, you would need how many linear? 3. If you introduce a quadratic, because you have 2 quadratics.
No.
Why not?
Because of how you word.
Oh yeah, if you have a quadratic times a quadratic, that would create a quartic, a 4th degree, which would have 4 zeros, not the 3 that we want for a cubic. Say again. You could do one linear and one quadratic. Okay, so here's what we're going to do. I want you to analyze the linear and quadratic functions that are shown. Notice when we get over to here for a, b, so on and so forth, they might want 2 imaginary zeros and a real 0. So, or we might want to look at the y-intercept for part B. So what should we probably do looking at those 8 different functions before we start trying to put them together? Huh? Yeah, should we probably identify what those zeros are? Yeah, they might be important. Okay. What else can we kind of look at? Anything else? Say again. Okay, the degree, which ties into those zeros, but what else? Come on, there's some other things. Look literally at B. What might we want to pay attention to? Look at B. The y-intercept, right? That y-intercept might be kind of important. Lastly, and I will point this out, you definitely want to think about the shape of that function, not just the zeros, right? When I look at this, I immediately recognize zeros, but I also recognize where that function is going to be roughly when I graph it. When I look at this function, I know roughly where it's going to be when I graph it. So think about those kinds of things. Pay attention to the zeros. So go ahead and analyze those. Yeah, let's go to the boards, and what I want you to do is, I want you to say like, no, we don't have enough time for that. Let's do this instead. Group 7, that's where y'all are, right? Group 7. I want you all to analyze f of x and m of x. Group 2, I want you all to analyze g of x and p of x. Group 4, h of x and r of x. We're just going to have to double up. Group 6, j of x and w of x. Group 5, let's get you all to g of x and p of x. Group 1, h of x and r of x. So identify your 4 or your 2 that you're analyzing. Analyze those 2 functions. We'll come back together in just a couple minutes to talk about the features that we see there. What are your questions? All right, let's identify those features that we can get.
Which one?
Oh, guys, sorry, just working your groups. We don't have time to. I guess if you're only doing 2, yeah, you can go work at the boards. I don't know what I'm doing. Go work at your boards. Jordan, do you know where you're You can stay there, that's fine. Come on, guys, hurry, Matt. We gotta focus. We gotta get going. Yes, James. I think I assigned, yeah, these 2 right here. J and W of X. So you're looking at those, analyzing those things we talked about, like the zeros and different things like that. Other features that you might want to notice about those functions.
Okay.
Make sure you label which function you're looking at. Guys, make sure you label which functions you're looking at.
I'm gonna just go for
There would only be one, and it would be x equals
set up as X plus.
Yeah, p of x is x squared.
We also have to find a y value.
So we look at the shape and stuff too. If like J rays only has one x-intercept, we know that it's correct for a linear function.
I don't know, that's all I should do. Last time we did a calculation, got calculators for you think I was there? Why you know how to find a y I didn't even draw.
Sorry, she just texted me. Yeah. I'll just record it, please, let's do it later.
Yeah.
You leaving? Huh?
What'd you say that?
You have to bring Alexander
Bring Alexander Hamilton here.
No. That's what people already say is he looks like me. I don't know.
Think he wasn't tall?
No.
I love baby.
Because your wife's awesome.
Well, we're both pretty short. Our family's a little bit taller than I am.
What if he gets like 6'3"? That's hilarious.
Is he bald?
It's just fair.
He came out here. All right, let's say we got 60 more seconds, and then we're gonna have a whole class discussion. Get your different things down, different details about those functions.
That's negative.
Tristan, your pause.
Can we click balance on?
No, you're not.
So we're in some trouble with P of X. What are you gonna do next? First off, show your work all the way.
Was it 300?
So -1 is equal to x squared. That's where you are. What are you gonna do to solve that equation? Yeah, you multiply by something. Square root.
Is that how you do it, Dan, or not?
Cole's actually good.
Oh yeah, what is square root of -1?
Are y'all not copying on
It's the imaginary number I.
It's because you
But
were
I'm missing something.
Okay, what about the y intercept?
This one is graphic, but it's not.
Can you take the square root? 5,
It won't be.
4, 3, 2, 1. Head back to your groups, please. Thank you.
So confused.
I do know.
Thank you. Thank you. Thank you. Thank you. All right. So let's focus and talk about these things. So when I look over here, f of x or y equals x, what did we see right away?
It was a line.
Huh?
It was a line going through the origin.
Okay. What else? Oh, come on. There's some other things we should know.
Positive.
What's positive?
The line.
I would say this. Lines can't be positive because right here the y values are negative. Here the y values are positive. So what are you referring to as positive? Focus. Huh? It's increasing because what's positive? The slope is positive. Thank you. All right. I didn't hear it, but I'll point this out. One, we're skipping this detail. What's the x-intercept? 0, comma. Notice that's also the y-intercept, right? My slope was 1, right? Guys, if we're talking about a linear function, you should always think about that slope. Slope is 1. Okay? You could do a quick little sketch if you wanted to, right? It is going through the origin. It's got a slope of 1 there. What about m of x equal to x squared? What did y'all say about that one? It's a parabola. What does it look like?
It's on like at 0, 0.
So, what's at 0, 0?
The vertex.
The vertex, right? There's nothing else happened to it. Y equals x squared, vertex of 0, comma 0. By the way, guys, you're going to need to use these. I would write them down in my book so that I can complete these other parts later. If that wasn't clear already. Okay. G of x. What should we know about it? So x equals -1 is the 0. Okay. X equals -1 is a 0. What else should we know immediately? I'll say there's one other point you should immediately know. Hey guys, what form of a line are we looking at? It's what? Slope. Intercept form. So what should we know immediately? The y-intercept. What is that y-intercept? 0, comma 1. Remember the 0 was x equals -1, right? Okay. And then a slope of 1. So that gives us enough information because if I know that I have a y-intercept of 0, 1 and an x-intercept of -1, 0, I can easily sketch that graph and use that information. What about p of x? What do we know about it? I had two groups working on p of x, right? Who was the other group? Okay, what did y'all see about p of x? The 0 was x equals plus or minus what? Oh. What is the imaginary number? Ah, right. Okay, I want to talk about two things, especially based on the test that I was grading. I need to emphasize this. A lot of us, especially with something like w of x, we've gotten really comfortable with just setting our factors equal to 0, right? So if I have w of x, I think not everyone, a whole lot of us literally just went straight from here to x minus 1 equals 0 and x plus 1 is equal to 0. Using what property right there? Zero product property, right? However, in a case like this, 1, you can't use the zero product property. 2, is that even equal to 0 yet?
No.
So guys, we got to remember to slow down and look at the basics first. You don't have factors here to set equal to 0, but you're looking for what again? Well, you're looking for zeros. So what do we know? Y should equal 0. Go back to those foundations and slow down and do those basics first. The reason I bring that up is right here, 0 is equal to x squared plus 1. That's what allows me to find those zeros. Similarly with w of x, 0 is equal to negative times x minus 1 times x plus 1. Now I can use the zero product property. Okay? Please pay attention and slow down and look at that small detail that if I'm looking for zeros, I need to substitute 0 in for y. It was small, but it was something that prevented a lot of us from scoring higher on that rubric on the test. Maybe it prevented a 4 or a 4 plus. Maybe it kept you at a 3 or a 3 plus. Okay, but yeah, solving from here, right? Group 5 and Group 1, y'all both worked on this. What did you do next?
Oh, what?
To find these zeros.
-1 on both sides.
So -1 is equal to x squared. And with the real numbers, a squared number does not equal -1, but with the imaginaries it does, right? You take the square root. Plus or minus I is equal to x. So if you were asked for imaginary zeros, which function could you be using? P of x. Right? At least so far, it's the only one we found that has imaginary zeros. Does anyone know what P of x would kind of look like if I were to graph it though? It wouldn't touch the x-axis, right? Specifically, I would point out, we know that if you think about it in standard form, it has what y-intercept? 0, comma 1. If you think about it as vertex form, it would have a vertex of 0, comma 1. And if you think about it in terms of just this x squared, aren't I literally taking x squared and then just adding 1 to it? Okay, so this isn't something we've been able to study this year, but it's going to shift it up 1. That is what p of x looks like. Notice, what does it not intersect? The x-axis, right? So I would have a quick little sketch of my p of x there to make sense out of it. Right? It's just that parabola shifted up a little bit, never intersecting the x-axis. Okay, we're going to have to move a little bit quicker through these last 4. The p of x was the only one really that I wanted to spend some time on. We'll have to use all this tomorrow. Alright, so h of x, for the groups that had that, what do we know about that function? X equals 1 is the what? 0. What else do we know? It has a positive slope. Specifically, the slope is 1, right? It's understood to be a 1 in front of that x. Anything else about that function we should immediately know? Y-intercept. Exactly. Right? 0, -1 for that y-intercept. Okay, so that 0 is x equals 1 with a multiplicity of 2. So what does that tell us about this parabola? What is it? It bounces at what x value? So there's x equals 1, and it's going to come down, it's going to bounce, meaning what's at the point right there? The vertex. Ah, there we go. Right? There's my vertex. I have a rough sketch of it. And it gives me that multiplicity of 2. What are y'all's questions up to this point? Again, I see a lot of us sitting around not sketching these out. You need a picture of these graphs to be able to do later parts of this. Okay? J of x. I'll wait a second for you to copy that down. Once we finish going through these 8 equations, we'll pause and you'll have enrichment. What? Okay. J of x, what do we know? Who had J of x?
It has a y-intercept, or
Y-intercept of what?
an x-intercept of -1, and he said a y-intercept of 1.
So that's my 0 and a y-intercept of what?
1.
Let's check this one again. There's my y-intercept. What's the slope? -1, right?
Mm-hmm.
Meaning it goes down 1 to the right 1?
Yeah.
Does that have an x-intercept of -1? Nope. I know exactly why y'all did that, right? Because the +1, we took the opposite of it, right? But we need to slow down, guys, and think through the idea of a 0. Because if I substitute 0 in for j of x, what am I going to do to solve that equation? Subtract 1 from both sides, right? And there's that -1 you're referring to, but notice -1 is equal to negative x. I don't know why it did that though. I thought I got everything fixed so it didn't do that anymore. So 1 is equal to x, right? And so we would want to notice that. And then w of x. Oh, and so, yeah, notice and be careful with like a sketch of